Righty dighty do. Hello everyone. Hope you guys are doing well. I'm back again with another tutorial on Terraform and DevOps related stuff where I will be talking about Google Cloud and how to use Terraform to create your infrastructure, automate all the tasks, and you don't have to like go make server and do those click. Just have one Terraform like a script or like those TF files, which are Terraform files, which will do the job for you, and you can just one place to make changes and create your whole Terraform journey. Yesterday, we covered just the basics and the introduction to what is Terraform and stuff like that. Today will be different because today we will be working towards our uh, more towards our lab stuff, right? Um, and that will be fun in my opinion because labs are like where you can learn a lot more and with Google. And I will say this, like labs are one of the best ways to do, and that's the reason I have like those credits extra spent some money on those credits because that's one of the ways you don't have to like go through the nitty-gritty of like creating your own cloud um, platform, creating your own account and stuff, making sure nothing is getting overcharged, stuff like that. And so credits are one of the best ways. This one I'll start sharing the other screen here in a second. You will see the transition. And instead of display capture today, yesterday you were able to like I've watched my own videos a lot because I want to see how things are going, how people are what is the experience, right? Basically. So what I realized was it is kind of hard and cumbersome, kind of like it's kind of annoying when people like with even me think, right? Like hard to understand what's going on with some of things coming up and out, right? So what I'm going to do today is just Google and I'll start here the transition 3, 2, 1. Last thing I want to make sure you guys can hear me and hear the audio that's in the one sec. There we go. Great. So now hopefully you guys can see me, hear me, and you can see the Google Cloud. I will increase the font just for you guys. Great. So now hopefully you guys can see. The good part about these, I can just check exactly how I'm like sounding and stuff. And one thing again, I'm working on an interesting thing is like my audio. I know it's like kind of rough, so hard to pay attention to. So one thing I'm working towards is making it a bit smoother for ears so you can hear for longer. That's one thing I'm doing. So hopefully that helps in future. Um, and that being said, let's jump into our Google Cloud journey. We'll just refresh this here. 14% complete. We did like the introduction where we talked about Terraform, different files needed, why it is good, and blah blah blah. Now we are working towards the terms and concepts. We will have a lab and a quiz at the end of this, which will be fun to do. And we will be writing some of the infrastructure code. So we'll try to do both of these, and then for tomorrow we'll read the last two. So let's get going. Terms and concepts, and I'll make sure you guys can hear
Hi
this.
there. Welcome to Module 2, Terms and Concepts. This module elaborates on the Terraform workflow that was introduced in Module 1.
Terms and concepts.
Now, this is going to be a very short module. Welcome to Module 2, Terms and Concepts.
Okay, you guys can hear this, so that's good. Just want to make sure. I'll just start again with the whole video. Here we go.
Hi there. Welcome to Module 2, Terms and Concepts. This module elaborates on the Terraform workflow that was introduced in Module 1. Now, this is going to be a very short module. While there's a lot to talk about how to author infrastructure, this module explores the foundation concepts you'll need to be familiar with before getting into the details of code constructs such as resources, variables, and output values. It includes key concepts, terminology, and the basics of HashiCorp language or HCL. Are you wondering what HCL language looks like? What do resources mean in the Terraform world? Then this module is for you. We will cover each phase of the Terraform workflow from author to apply. You'll learn to create basic configuration files and explore the HCL language. HCL is similar to JSON, easy to learn and powerful for configuring infrastructure resources. You'll learn about the initialize phase, which includes providers. Next comes the plan and apply phase, where you'll examine the purpose of a few important Terraform commands. We will also cover an optional phase called validate, where you will learn about the Terraform validator tool. And it describes how to create, update, and destroy Google Cloud Infrastructure resources using Terraform. We will conclude with a hands-on lab to apply your knowledge and a recap of topics covered in the module. Let's get started.
Did I do?
Let's get started with an overview of Terraform configurations and the HashiCorp language. Let's get started with an overview of Terraform configurations and the HashiCorp language. This course focuses on the core Terraform workflow, author, initialize, plan, and apply. In this module, you'll explore how these individual phases fit together to transform code to cloud resources. Let's start with the author phase, where you write Terraform code in .tf files. Before writing code, start by creating directories for a Terraform configuration. A Terraform configuration is a complete document in the Terraform language that tells Terraform how to manage a given collection of infrastructure. The configuration is stored with a .tf extension. A Terraform directory can consist of multiple files and directories. A Terraform configuration consists of a root module, also referred to as root configuration file, and an optional tree for child modules. Child modules are optional and can be variables, outputs, providers, and so forth. You can have a series of resources and other code constructs with a single root configuration, but the best practice is to logically separate them into different files. The root module is the working directory in which Terraform commands are run. In that directory, Terraform will look for any .tf files and use them to create a plan and infrastructure elements. Now that you know how to create a directory structure, let's explore the language used for Terraform configurations. The language used to write configurations is the HashiCorp configuration language, or HCL. Generic HCL syntax is shown in this example. HCL is used to create and manage API-based resources, predominantly in the cloud. Resources are infrastructure objects such as virtual machines, storage buckets, containers, and networks. Terraform uses HCL to define resources in your Google Cloud environment, create dependencies with those resources, and define the data to be fetched. Despite some using
Hold on.
configurations,
So
now
if
that
this
you know
is
how to create a directory structure, let's explore the language used for Terraform.
so block type. Okay, what type of block it is? Let's take an example from one of the uh, cloud uh, samples. Let me increase the HCL. I want to give an example as we are doing because that's like way easier to understand and stuff. Hmm. Hello world one is yeah good one to start with main.tf. Here it is. So this is the provider block type. So with the block type we had to provider resources variable. So that's what block type means. Okay. Next thing we are looking at, okay, the name. When we look here, You just have it popped out as a second window. And this is how you do it, right? Yeah. Okay, I'm learning Windows. That's a good thing. So here we have block type, block label, another label, body, identifier, and expression. Okay. So with this, we have this is the type, the label, another label, that's the one, different variables and their arguments and stuff. So like zone, this, then we have like another block inside it. We can have multiple blocks and stuff. Okay, cool.
Configurations. The language used to write configurations is the HashiCorp configuration language or HCL. Generic HCL syntax is shown in this example. HCL is used to create and manage API based resources, predominantly in the cloud. Resources are infrastructure objects such as virtual machines, storage buckets, containers, and networks.
Okay, so basically the ones, so here in this case, source, right, will be compute instance. Okay, here this is a project. We have network interface, disk, and all those kind of stuff. Okay. Okay, there's just one guy who did it. This would be like nice. I'm just thinking in terms of like if we have this, only how many people have worked on this? Just one guy, I guess. So maybe we can just improve this and just add more samples, which are like basics. Okay. That would be a good project if anybody wants to take because open source helps in getting better jobs and like looks cool on your it's good to do it because everybody uses open source. I use so many open source stuff. So I want to like at one point of my life want to contribute to open source.
Such as virtual machines, storage buckets, containers, and networks. Terraform uses HCL to define resources in your Google Cloud environment, create dependencies with those resources, and define the data to be fetched. Despite some commonalities, HCL is a configuration language, not a programming language. It's a JSON based variant that's human and machine friendly. The simplicity of HCL makes Terraform accessible to developers. HCL includes a series of primitives such as variables, resources, outputs, and modules.
VC
It
provider
does
as
not
well.
include any traditional statements or control loops. The logic is expressed through assignments, count, and interpolation functions. Let's explore HCL in detail. Blocks are lines of code that belong to a certain type. Examples include resources, variables, and outputs. A block can be simple or nested to include another block type. Arguments are part of a block and used to allocate a value to a name. Some blocks have mandatory arguments while others are optional. Identifiers are names of an argument.
I will say like based on what you are like uh, so people who don't get it based on like what type of resource you are asking to develop, what you want to provision. That's the one where the arguments that will whatever type of resource you're trying to provision that will define what type of arguments and what type of arguments are optional and non-optional, like the ones that are necessary. So for example, in case of compute instance you need to give a name all the time, but the optional one will be do you want a static IP or not for it, stuff like that, or which subnet you want and stuff like zone, things like that.
Have mandatory arguments while others are optional. Identifiers are names of an argument, block type, and any Terraform specific constructs. Identifiers can include letters, underscores, hyphens, and digits, but cannot start with a digit. Expressions can be used to assign a value to an identifier.
Oh,
Identifiers can include letters, underscores, hyphens, and digits, but cannot start with a digit.
okay.
Expressions can be used to assign a value to an identifier within a code block. These expressions can be simple or complex. Comment syntax starts and ends with a hash for a single line comment. Remember, HCL is declarative in nature, which means you define the end state of an infrastructure. Therefore, the order of the blocks or files does not matter.
I see. So because it's at the end, you don't have to make sense because you don't have to tell, okay, what are the different types of steps to take that will do. It will just, you tell, okay, this is the destination you have to reach, it will reach basically. That's the whole point.
We have covered Terraform configurations and the HashiCorp language. Now, let's discuss the common terms and concepts that you encounter during the author phase of the Terraform workflow. Resources are code blocks that define the infrastructure components. A resource is identified by the keyword resource, followed by the resource type and a custom name. The resource type depends on the provider defined in your configuration.
So the one we, sorry, I have to go back. So resource type we had was instance, TCP instance, and we had the name. So let's just see here. Okay, this is more like Mac now. Okay, cool. That's helpful for me. I am a Mac guy. So this is much better. I can have multiple desktops. I had no idea about this. So that's good thing to know. I knew like we could change like this, but I had no idea about this. So that's good. So this is the resource type, and this is the name of the resource we have given. Example. Okay.
Resources are during the author phase of the Terraform workflow. Resources are code blocks that define the infrastructure components. A resource is identified by the keyword resource, followed by the resource type and a custom name. The resource type depends on the provider defined in your configuration. Inside the curly brackets are the resource arguments where you specify the inputs needed for the configuration. Terraform uses the resource type and the resource name to identify an infrastructure element. The keyword resource type is a custom name. The resource type depends on the provider defined in your configuration.
So resource type. So for example, Google will have Google Compute Instance. Azure for it, Azure will be Azure Virtual Machine. AWS will be EC2 instance, right?
Inside the curly brackets are the resource arguments where you specify the inputs needed for the configuration. Terraform uses the resource type and the resource name to identify an infrastructure element. The keyword resource identifies the block as a cloud infrastructure component.
Hmm.
The keyword resource identifies the block as a cloud infrastructure component.
Keyword resource identifies the block as a cloud infrastructure. Okay.
The resource type is Google Storage Bucket, which identifies the Google Cloud resource. This terminology is Terraform specific and the convention cannot be customized. The resource type varies based on the provider defined. The resource name is example bucket. Terraform uses the resource type and the resource name together as an identifier for the resource. This example assumes that Google Cloud is defined as a provider and shows a cloud storage bucket and a compute instance. The
So this one we have created a storage bucket here, example bucket, unique bucket name, which we given location, again, compute instance, stuff like that. Okay.
This example assumes that Google Cloud is defined as a provider and shows a cloud storage bucket and a compute instance. The arguments differ based on the resource type being defined. For the Google Storage Bucket resource, you must specify the name and location to successfully create the resource. For the Google Compute Instance resource, you must specify the name, machine type, and zone. Tags are optional. You can use separate files, for example, files for instances, storage buckets, and datasets if you have lengthy resource configurations. Providers implement every resource type. Without providers, Terraform cannot manage any kind of infrastructure. In the
Mm,
providers.tf file, you specify the Terraform block that includes the provider definition you will use.
I see. So here provider will be the cloud provider. If it require for us, it will be Google. Okay. This is a source of the Terraform language. So variables, right? Resource, Google, compute instance, all those will be coming. provider, we have to give the project ID. So different projects will have this. Okay, so not like one. For example, let's say if I want Jenkins for multiple projects, I need to like architect it basically for my stuff.
Terraform any kind of infrastructure. In the providers.tf file, you specify the Terraform block that includes the provider definition you will use. Terraform downloads the provider plugin in the root configuration when the provider is declared. Providers expose specific APIs as Terraform resources and manage their interactions. Provider configurations declared. Providers expose specific APIs as Terraform resources and manage their interactions.
So the one I was talking about, so for AWS it will be EC2. So this is here. If you define here AWS, then that will need EC2 instance, or Azure virtual machine for Google is compute instance.
Provider configurations belong in the root module of a Terraform configuration. An example of a provider block is shown on screen. The resource argument provides the global source address for the provider that you intend to use. In the above example, the source argument is assigned to the Terraform registry URL HashiCorp/Google. The name Google is the local name of the provider to be configured. To ensure that the local name is configured correctly, the provider must be included in the required provider block.
Okay, so this Google here is coming from this Google, right? Like arguments such as project and region must be declared within the provider block. Okay,
URL HashiCorp's address for the provider that you intend to use. In the above example, the source argument is assigned to the Terraform registry URL HashiCorp/Google. The name Google is the local name of the provider to be configured. To ensure that the local name is configured correctly, the provider must be included in the required provider block. The arguments such as project and region are specific to the Google provider. When a provider block is not included within a Terraform configuration, Terraform assumes an empty default configuration. You can also assign a version to each provider. The version argument is optional but recommended. Version arguments constrain the provider to a specific version or a range of versions to prevent downloading a new version that may contain breaking changes. If the version isn't specified, Terraform will automatically download the most recent provider during initialization. Breaking changes. To prevent constrain the provider to a specific version or a range of versions to prevent downloading a new version that may contain breaking changes.
it's like basically just like with Python or Java when you're installing, specifically in Python, right? Like you define a version in the requirements.txt file. You don't want the late. You can just specify the exact version you want because the latest one can break your application. So that's good. It also has that in the
If the version
providers.tf.
isn't specified, Terraform will automatically download the most recent provider during initialization. Variables are used to parameterize your configuration. Input variables serve as parameters for Terraform, allowing easy customization and sharing without having to alter source code. Once a variable is defined, there are different.
Let me do one thing. I just realized my face will be is probably coming in the way for some. So I'm just going to make even myself even a bit more smaller so that it's easy for you to have a look and you're not missing any data basically. One sec. That's why I'm changing in the background. So now I am even smaller, more smaller. Hopefully that is helpful. Now you'll see 1, 2, 3 the change. Okay, cool. Let me know if this is much better. I see 3 viewers, so that's awesome. Go back here.
If the version isn't specified, Terraform will automatically download the most recent provider during initialization. Variables are used to parameterize your configuration. Input variables serve as parameters for Terraform, allowing easy customization and sharing without having to alter source code. Once a variable is defined, there are different ways to set its value at runtime: environment variables, CLI options, key or value files, and so forth. You can define a resource attribute at runtime or centrally in a file with a .tfrs extension.
Okay, so variables, parameter resources, arguments to eliminate hard coding its values. So we don't want to hard code, that's why which is a good thing. Example, region, project ID, and those stuff. Define a resource attribute at runtime and centrally in a file. So this is main.tf, variable.tf, Terraform, tf vars, define values at runtime. So location here, variable location, CLI apply.
Set its value at the source code as your configuration station. Variables are used to parameterize your configuration. Input variables serve as parameters for Terraform, allowing easy customization and sharing without having to alter source code. Once a variable is defined, there are different ways to set its value at runtime: environment variables, CLI options, key or value files, and so forth. You can define a resource attribute at runtime or centrally in a file with a .tfrs extension. You can also easily separate attributes from deployment plans. In this example, main.
So if people you might be having issue, I also like sometimes used to have. Right now, I'm able to connect majority of the dots because I did worked on some Terraform stuff recently. So, but once we start going into the lab, you will things will connect. So just
Separate
stay with me.
attributes from deployment plans. In this example, main.tf declares a cloud storage bucket. The location attribute has been parameterized because it's declared as a variable in the variables.tf file. By parameterizing the attribute, you can define the values of these variables at runtime. You'll learn more about variables in the next module. Outputs.tf hold output values from your resources.
Hmm.
Resource instances
Nice.
managed by Terraform each export attributes whose values can be used elsewhere in configuration. If needed, output values are a way to expose some of that information. Some resource attributes are computed upon their creation. For example, a self link of the resource or the URL of a bucket is generated upon bucket creation. These computed attributes might be required for accessing the bucket or uploading objects. With an output value, you can output this information and make it accessible. The label after the output keyword is the name, which must be a valid identifier. In a root module, this name is displayed to the viewer. In a child module, it can be used to access the value. The value argument takes an expression that returns the module. You can output this information and make it accessible. The label after the output keyword is the name, which must be a valid identifier. In a root module, this name is displayed to the viewer. In a child module, it can
Okay,
be required
let's go
treated
back a bit.
upon bucket creation. These computed attributes might be required for accessing the bucket or uploading objects.
Mm-hmm.
With an output value, you can output this information and make it accessible.
Nice.
The label after the output keyword is the name, which must be a valid identifier.
So label after the output keyword. So this is bucket URL. This is what you see here, and its value will be equal to whatever this when we are creating the resource. Okay, the bucket resource we mentioned in the previous .tf file main.tf, and my bucket will probably be the name of the is probably I think yeah it was the name of the bucket itself, and then that's URL. So this is here. Okay, my bucket, yeah.
In a root module, this name is displayed to the viewer. In a child module, it can be used to access the value. The value argument takes an expression that returns the result to the user. Terraform saves the state of resources that it manages in a state file. By default, the state is stored locally, but it can also be stored remotely.
Mm.
Remote storage is often the preferred method when working in a team environment. Do not modify or touch this file. It's created and updated automatically.
Mm-hmm.
States are covered in detail in an upcoming module. Finally, a Terraform module is a set of Terraform configuration files in a single directory. Even a simple configuration consisting of a single directory with one or more .tf files is considered a module. Modules are the primary method for code reuse in Terraform. They are reused by specifying the source from which the code can be retrieved. Sources can with one or more .tf files is considered a module. Modules are the primary method for code reuse in Terraform.
Mm-hmm.
They are reused by specifying the source from which the code can be retrieved. Sources can either be local or remote. You can use an upstream module from the HashiCorp module registry or create your own.
Okay, so there is like registry. So just like Docker, we have Docker container registry. For source code, we have our Gitty. I mean, I forget I call it Gitty. So GitHub and GitLab. So we have that HCP. Okay, will it be better to just put it in a GitHub? Something maybe. Hmm. Just thinking, what is this? OpenAI. Maybe I'll look at it later.
So you missed.
I'll look at it later. Looks like cool though. Need to look into this. So probably we'll only be able to cover this one today. Like not like video mean, but like this whole concept, terms and concept, because I think this is like a lot of knowledge we need to cover
Once
slowly.
Terraform is installed on your machine, you can use commands on your root module to interact with Terraform. Common commands covered in this module include Terraform init, Terraform plan, Terraform apply, Terraform destroy, and Terraform FMT. Terraform init is used to initialize the provider with a plugin. Terraform plan provides a preview of the resources that will be created after Terraform apply. Terraform apply creates infrastructure resources. Terraform destroy, as the name suggests, destroys infrastructure resources. And Terraform FMT auto formats to match canonical conventions.
Mm-hmm.
The Terraform init command is run during the initialize phase. It's the first command to run after creating a configuration or checking out an existing configuration from the version control. Terraform init ensures that the Google Provider plugin is downloaded and installed in a subdirectory of the current working directory, along with various other bookkeeping files.
So this in it, like if you have done some coding, right, you might have recognized this from um, Git init, or I think Node init or npm. I think it's Node init, which like put in npm and all those stuff. So the good part is here, like we are like going through those similar architecture and like similar commands. So that's a good thing.
Directory of the current working directory, along with various other bookkeeping files. The provider block includes a source attribute specifying where the provider plugins will be downloaded from. Terraform uses a plugin based architecture to support the numerous infrastructure and service providers available. Each provider is its own encapsulated binary that is distributed separately from Terraform itself. The Terraform init command will automatically download and install any provider binary for the providers to use within the configuration. In this case, the provider is Google. After you run Terraform init, a hidden directory called .terraform is created inside the current working directory. You will see an initializing provider plugins message letting you know that Terraform will find the latest plugin and download the associated files. The output of
So in the provider where we mention and all the variables, if we don't mention the version, downloading the latest and stuff. Okay.
you will see an initializing provider plugins message letting you know that Terraform will find the latest plugin and download the associated files.
Mm-hmm.
The output of the command tells you the provider version that Terraform has installed, in this case, version 4.21. Terraform plan creates an execution plan detailing all the resources that will be created, modified, or destroyed upon executing Terraform apply. When Terraform plan is run, Terraform reads the current state of existing remote objects to ensure that Terraform state is up to date, compares the created.
One thing, okay, before we go inside mode plan, I want to check if you were able to see. You guys cannot see what I was trying to show before, right? But let's say if I go like this, you guys can see stuff like this. Oh, interesting. We were not able to see the GitHub things I was showing. Oh no, you can see it. Never mind. Interesting stuff. So if I just share here, anything. This is interesting. OBS has done a good job with that.
Files.
Let's go
The
back to
output
the
of the
provider.
command tells you the provider version that Terraform has installed, in this case, version 4.21. Terraform plan creates an execution plan detailing all the resources that will be created, modified, or destroyed upon executing Terraform apply. When Terraform plan is run, Terraform reads the current state of existing remote objects to ensure that Terraform state is up to date, compares the current configuration to the prior state and notes any differences, and builds an execution plan that only modifies what is necessary and reach your desired state. Terraform plan notes any up to date current state of existing remote objects to ensure that Terraform state is up to date, compares the current configuration to the prior state and notes any differences, and builds an execution plan that only modifies what is necessary and reach your desired state.
So basically it creates an execution plan on its own, right? Plan, following function will be created. This is the resource. Force destroy fall ID. Location is US. Name is this. Storage class we have defined. Okay, plan one.
Terraform plan does not actually create or change any infrastructure
It creates a
resources,
plan.
but instead provides you with an opportunity to preview your infrastructure changes before applying them. For example, you might want to run this command before committing a change to version control to be sure that it will behave as expected. Optionally, you can save the generated plan to a file on disk, which you can later execute by passing the file to Terraform apply as an extra argument. Terraform apply executes the actions proposed in a Terraform plan, creates the resources, and establishes the dependencies. The symbols next to the resources and arguments indicate the action performed on the resource. This executes the actions proposed in a Terraform plan, creates the resources, and establishes the dependencies. The symbols next to the resources and arguments indicate the action performed on the resource. The plus next to the resource means that the Terraform will create this resource.
The plus next to the resource means that Terraform will create this resource. I see. So I think there will be negative
Terraform
to
also shows the attribute that will be set. -/+ means that Terraform will destroy and create the infrastructure rather than updating it in place. The tilde means that Terraform will update the resource in place. The minus indicates that the instance and the network will be destroyed. As with apply, the tilde means create the infrastructure.
-/+ means it will destroy and recreate. I see. Okay.
Rather than updating it in place. Nice. The tilde means that Terraform will update the resource in place. The minus indicates that the instance and the network will be destroyed. As with apply, Terraform shows its execution plan and waits for approval before making any changes. If the plan is created successfully, Terraform pauses and waits for approval before proceeding. If anything in the plan is incorrect or unsafe, you can abort here without changing your infrastructure. If Terraform apply fails, read the error message and troubleshoot the issues. Just like with Terraform Plan, Terraform determines the order in which things must be destroyed. For example, Google Cloud won't allow a VPC to be deleted if it still has resources. Terraform waits until the instance is destroyed before destroying the network. HCL code conventions are as follows. Separate the meta arguments from other arguments by placing them first or last in the code with a blank line.
Okay, so meta arguments, okay, not in between, like either in top or.
Indent your arguments with two spaces from the block definition. When two or more arguments are defined in a given block, align the values at the equal sign. When a block includes a nested, align the values at the equal sign. Or
Wait,
more
what?
arguments are defined in a given block, align the values at the equal sign.
I don't get that. So if there are two or more line values at equal sign, what does that mean? Multiple spaces, that makes sense. Unaligned equal signs. These are not aligned either, but okay, I think there must be more space here. Okay.
Sign. When a block includes a nested block, place the block following all the arguments.
Okay, block should be after all the arguments.
When your code includes multiple blocks, separate them with a blank line for readability. Running Terraform FMT on your modules and code automatically applies all
Yeah,
these
okay.
formatting rules and recommended styles to assist with readability and consistency. Terraform FMT automatically maintains consistent formatting, so you don't have to manually change configuration to ensure it meets the standard. The last command to cover in this module is Terraform Destroy, which destroys resources. Terraform Destroy is similar to Terraform Apply, but it behaves as if all resources have been removed from the configuration. Terraform is sometimes used to Terraform Destroy is similar to Terraform Apply, but it behaves as if all resources have been removed from the configuration.
Mhm. Similar to Terraform apply. Destroy is similar to apply, but behaves as.
Apply, but it behaves as if all resources have been removed from the configuration.
Mm.
Terraform is sometimes used to manage ephemeral resources for development purposes. In this case, you can use Terraform Destroy to conveniently clean up temporary objects once you're finished with your work. You can also destroy specific resources by specifying a target in the command.
You can destroy specific resources by specifying a target in the command.
Destroying your infrastructure is a rare event in production environment. But if you're using destroying your by specifying a target in the command.
Okay.
Destroying your infrastructure is a rare event in production environment. But if you're using Terraform to create multiple environments such as development, testing, and staging, then destroying is often a useful action. Use Terraform Destroy carefully. It will destroy any resource and the data associated with it. For example, if there's data in a bucket, be careful when running Terraform Destroy as that data cannot be recovered.
I believe this Terraform destroy is like Docker system prune, something like that command, if I'm not wrong, where it's powerful but very careful. Be very careful playing with this. It's like playing with fire, be careful. Oh yeah, I know why this is coming. I was working on intro ID, so now all the YouTubes are mixed.
Let's think back to the Terraform workflow and explore the validate phase. Between the plan and apply phases is the option to validate. During this phase, pre deployment checks are run against organizational policies. The Terraform Validator is a tool for enforcing policy compliance as part of an infrastructure CI CD pipeline. It's also incredibly useful in an infrastructure as code environment as it helps mitigate configuration errors that can cause security and governance violations. Although validation is optional, the Terraform Validator is a useful tool in an IAC environment. Businesses are shifting towards errors that can cause security and governance violations. Although validation is optional, the Terraform Validator is a useful tool in an IAC environment. Business is a useful tool in an IAC environment. Businesses are shifting towards infrastructure as code, and with that change comes the risk that configuration errors can cause security and governance violations. Furthermore, any organizations have compliance and governance policies in place that must be adhered to. For example, perhaps there are data residency laws in place, and your governance team must ensure that resource creation is only allowed in certain regions.
Okay, so this is nice, like in terms of like I can have validator if I'm like moving my cloud, change switching cloud providers from one cloud to another, like AWS to GCP, Azure to GCP, have these validators in place already, so it can help me get that ISO certificate better. Okay, that's interesting to learn.
To address this policy, the security and governance teams can set up guardrails. These guardrails are in the form of constraints. Constraints define the source of truth for security and governance requirements. Constraints must be compatible with tools across every stage of the application lifecycle, from development to deployment to auditing. The Terraform validator is run by executing the gcloud beta terraform vet. Executing the command enforces policy compliance as part of an infrastructure CI CD pipeline. The tool retrieves project data with Google Cloud APIs so you can accurately validate your plan.
Mhm.
You can use the Terraform validator to detect policy violations and provide warnings or halt deployments before they reach production. The same set of constraints that you use with the tool can also be used with any other tool that supports the same framework. gcloud beta terraform vet is different from the Terraform validate command. Terraform validate is used for testing syntax and structure of your configuration without deploying any resources. The Terraform validator is used to ensure that the configuration adheres to the set of constraints. The configuration without deploying any resources. The Terraform validator is used to ensure that the configuration adheres to the set of constraints. These constraints automate the enforcement of the organization policies. With the Terraform validator, you can enforce policies at any stage of application development, remove manual errors by automating policy validation, and reduce learning time by using a single paradigm for all policy management.
Enforce policies at any stage. So we can have a dev. We don't need that dev staging.
Remove manual errors
Mm-hmm.
by automating policy validation, and reduce learning time by using a single paradigm for all policy management. Let's examine a few Terraform validator use cases and show how it can help different teams.
We have demo and lab intro. Okay.
Platform teams can easily add guardrails to infrastructure CI CD pipelines to ensure that all requests for infrastructure are validated before deployment to the cloud. This limits platform team involvement by providing failure messages to end users during their pre deployment checks. These messages tell you which policies they have violated. Application teams and developers can validate their Terraform configurations against a certain policy library to identify misconfigurations early in the development process. Before submitting Identify misconfigurations early in the development process. Before submitting to a CI CD pipeline, you can ensure that your Terraform configurations are in compliance with organizational policies, thus saving time and effort. Security teams can create a centralized policy library that is used by all teams across the organization to ensure and prevent policy violations, depending on how it is, thus saving time and effort. Security teams can create a centralized policy library that is used by all teams across the organization to ensure and prevent policy violations, depending on how.
Centralized. Okay. We can have like guardrails inside the CI/CD pipeline to make sure all the validations their application team and developers can validate, right? And then before deploying and stuff, and then
Your organization
security.
is structured, the security team or other trusted teams can add the necessary policies needed to meet compliance requirements.
Hmm.
Hi, this demonstration will help you become familiar with the Terraform configuration to create a compute engine instance. We will show you how to create configuration files and use the Terraform CLI to execute a few Terraform commands such as Terraform init, Terraform plan, Terraform apply, and Terraform destroy. While watching this demonstration, you will discover how easy it is to use and adopt Terraform to manage your Google Cloud infrastructure.
This is interesting. Uh, Give me 1 second, guys. Wait, I should not do like minimize this thing because I know you won't be able to see anything. It is blank right now. I just realized, yeah. Um, don't worry, it is coming up. I'm just okay.
Let's get started. For demonstration purposes, we are using Terraform on Cloud Shell. Terraform comes pre-installed on Cloud Shell. With Cloud Shell, you have command line access to your cloud resources directly from your browser, so you can easily manage projects and resources without having to install any tools on your local machine. Further, command line tools such as Terraform and other utilities are automatically authenticated so you can use them setup free. To verify the Terraform installation, enter Terraform in the command line.
Terraform Dash V is
You
my
can check the
favorite.
version of Terraform running on Cloud Shell by running Terraform version command.
Dash V. Do
As
version.
a first step, let's define the provider. To do this, we first create a folder called infra. Right click underneath your project to create new folder. Give it a name of your choice. Create a new file called main.tf to author the Terraform code. Before creating the resources, we define the provider so Terraform knows which provider to download. At this point, because you might not be familiar with the code and syntax, we leverage Terraform registry. Navigate to the registry. Under Google Cloud Provider, click the Use Provider button
Mm-hmm.
and copy the code underneath it. In the configuration
So let's
define,
just
the Google Provider
1 second here. Required providers, we have put Google with the source as this and version as this. Okay. So go to HashiCorp Google and get this
provider's
library.
source is defined as HashiCorp/Google, which is shortened for Terraform registry for Google Cloud. In this example, we already have a project created. Let's edit the configuration options to include the project and assign the project ID to it.
So Google, because of this Google provider, We have Google with the project ID here, and I think we need one more
Save the
argument.
configuration changes.
No region
Switch to Cloud Shell.
no region was
Change to the
fine.
current directory. Execute Terraform init. To
That's crazy
initialize with
boy.
changes,
So we are directly working in the cloud code.
save the configuration changes.
Okay. Yeah, good.
Switch to Cloud Shell.
Mm-hmm.
Change to the current directory. Execute Terraform init. To initialize Terraform and download the provider plugins. Let's next define our first Google Cloud resource, a Google Compute Engine.
Okay, let's hold on here. Resources given with Google Compute Engine instance coming because we have included Google. Terraform is the name of the resource we have given. Then project ID is coming from above, I guess. Um, Name is for the compute instance, machine type, zone, boot disk. Okay, network interface. Huh.
Let's edit the project ID
A copy
to our current project.
was above.
Save the code and return to Cloud Shell window.
One thing, if you have not noticed right here, if you see machine type is the biggest one, so two spaces from this is equals, and then equals are aligned after that.
Next, execute Terraform plan.
We have init, we have now plan.
Authorize when prompted. You can see a summary of Compute Engine instances created.
Plus means it's all those things will be created, right? So these things will be created, known after apply, known after.
Execute Terraform apply. To apply your configuration, the output has a plus next to Google Compute instance, which means that Terraform will create this resource. The sign varies based on the configuration applied. Beneath the resource update status, the attribute that will be set are displayed. When the value says known after apply, the value cannot be determined until the resource is provisioned. Review the output of the apply command to ensure that the resource configured are as per your expectations. If anything in the output seems incorrect or unsafe, enter no so that no changes are made to your infrastructure. The plan looks acceptable here, so we type yes. While we wait for the resources to be created,
Excuse me, I just wanted to point out its caption is not working, so I'm just shutting the caption off for this video. It's like wrong.
while we wait for the resources to be created, we switch to the editor to see that a Terraform state file is automatically created. The Terraform state defines the current state of the infrastructure. Let's verify the resource created on the Google Cloud Console.
The Terraform state is
The
created,
infrastructure.
right? And then it gives all the version, Terraform version, blah blah blah, resources created, and their schema version and everything. Okay.
Let's verify the resource created on the Google Cloud Console. You can see a Terraform resource is now being created in the region defined. We can also destroy the resources created by simply executing the Terraform destroy command. Let's navigate to the Cloud Shell and delete the resource we just created. The minus prefix indicates that the resource will be destroyed.
Hmm.
As with apply, Terraform shows its execution plan and waits for approval before making any changes. Enter yes.
Instead of yes, if you type anything, it won't be accepted.
You can see that the resource is now deleted. Let's verify the deletion on the Google Cloud Console. Navigate to Compute Engine, click VM Instances. You can now see the Terraform instance is no more available in the instance list. This completes the demonstration. In this demonstration, we defined a provider to download the provider plugins. We created a Google Compute Engine using Terraform. We used the command terraform plan to review the resource creation. We used the command terraform apply to create infrastructure resources. We then finally executed terraform destroy to destroy the resources we just created. Thanks for watching. Hope you enjoyed it.
I'm just thinking, so we need to have like those VS Code. I think I have to work on the VS Code, the plugins, and all those connections so it's easy for it to work. Crazy.
In this lab, you will use Terraform to create, update, and destroy Google Cloud resources. You will start by defining Google Cloud as a provider. You will then create a VM instance without mentioning network to see how Terraform passes the configuration code. You will then edit the code to add a network and create a VM instance on Google Cloud. You will explore how to update the VM instance. You will then edit the existing configuration to add tags and then edit the machine tag. You will later execute Terraform commands to destroy the infrastructure resources created.
Hmm. Alrighty, boss. Let's get some hands dirty. It'll be fun. We have 1 hour. Not sure if we need 1 hour. What I'll do, I'll be back in a second. I'll get some water. There's no water left. So, BRB, boys and girls. 1 sec. Alrighty. Get our hands dirty. Let's go. So we are looking at the lab, right? Infrastructure as code with Terraform. Let's see if you guys can see it well. You know, okay, hopefully this helps, right? Um, this makes it even worse. That's fine. Or maybe instead of, yeah, just little bit, yeah. Okay, this is it. This is what we have the best for now, I guess. So let's just get this one overview. So just to state again, we are in the infrastructure as code with Terraform. It takes 1 hour, 1 credit. It says it takes 1 hour. Should probably be less than that, right? Overview. In this lab, you will use Terraform to create, update, and destroy Google Cloud resources. You will start by defining Google Cloud as the provider. You will then create a virtual machine instance without mentioning the network to see how Terraform parses the configuration code. You will then edit the code to add network and create a virtual machine instance on Google Cloud. Sweet. So the two parts of this will be first we create an virtual machine instance and then we update it, and third at the end will is basically kind of destroy, but I'll say it's just two parts still. Third is nothing, right? Destroying thing. You will explore how to update virtual machine instance, how to update the virtual machine instance. You will edit the existing configuration to add tags and then edit the machine type. You will then execute Terraform commands to destroy the resources created. You will then execute Terraform command to destroy this. Objectives. In this lab, you will learn how to perform the following tasks. Verify Terraform installation, define Google Cloud as the provider, create, change, and destroy Google Cloud sources by using Terraform. Terraform installation. Sign in to the Google Cloud. For each lab, you get a new Google Cloud project, set of resources for a fixed time. Sign to Qwiklabs using incognito window. Probably we have to do this in a bit, but till then, let's just go this. Note the lab access time. For us, it's 1 hour. Make sure you can finish within that time. There is no pause feature. You can restart if needed, but you have to start at the beginning. When ready, click Start Lab. Note your lab credentials will be here. So that's the one of the worst part about with being live. It's like, let's say if somebody's watching, they can get those credentials and stuff. Note your lab credentials username will you will use them to sign in to Google Cloud Console. Click Open Cloud Console. Click Use another account. Copy paste credential for this lab into the prompts. If you use other credential, you will receive errors or incur changes. So basically, incur charges. So basically, use the lab one. Accept terms. Do not click End Lab. Okay. Let's start the lab, right? Oh, we can have tokens. I hardly think this will work. I just want to see. The token never worked in my opinion. Okay, we have this. Now one thing I have to do once first I will just add this information in incognito mode. Then I will like start sharing my windows properly because you guys can probably see everything, and then I don't want to have issues during the live stuff. Well, that doesn't work that well, does it? Nope, it doesn't. So one thing I have to do is display capture and turn off GCP. So you guys should all be able to properly see now. I'll just do 50-50 of this. So you can see I have like logged in to my Google Cloud from incognito using the credits given, right? Just work on this. Project ID, check Terraform installation. I'll do this. This is much better. Check Terraform installation, Cloud, Google Cloud, activate Cloud Shell. If a dialog box appears, click continue. So let's go to the console here, quick. Yep, Canada, I agree. There is no point in doing the email and update. So fine, this is our Cloud Shell. Activate Cloud Shell. The continue prompt will come. I think it said it's free for all users, right? So if it is free for all users, I don't have to work on my VS Code or something. Everything should be here. That's nice if it's free. On AWS, I think I have to pay. If prompted, or Azure, I know I have to pay. Click continue. Confirm that Terraform is installed by running the following command. Don't worry, you get a warning what version of Terraform is out of date, as the lab instruction will work with this one or later. So let me just increase. Can I increase just for this? Large. Okay, this should be good, right? Okay, you guys can't see it. Oh, I never transitioned. I'm an idiot. So what I did, right, logged into this, we have in incognito mode, I have launched using this button here, which is grayed out now, active Cloud Shell, right? We are in the Cloud Shell now. We are applying, we are at task 2, basically. Terraform version, we have put this here. Let's go see 1.7.2 on Linux AMD. Advanced my AMD is like advanced micro AMD. What AMD is? AMD 64 design, yeah. Advanced micro. It's interesting how big AMD is nowadays. Note, the available downloads for the latest version can be found on the Terraform website. Terraform is distributed as a binary package for all supported platforms and architectures, and Cloud Shell uses Linux 9064. The output should look like, do not copy, this is the example output. So for our case, it was 7 points. Your version of Terraform is out of date. The latest version is this. I'm okay with 1.72. Comes with pre-installed in CloudShare with Terraform already installed. You can directly have the infrastructure work done, right? Okay. So touch, if you don't know, is a Linux command to create a new file. So we are going to have touch here. I use nano all the time. They have a touch here. So if you see, I don't use touch. I use nano all the time. They probably are using nano. Copy this. So let's diagnose this. We are using Terraform in the, this is main.tf, so we are going to use Google. Let's give this source and stuff. Provider is Google. This word here. Region, project region stuff. I'm going to do is instead of Google, I will say GCP to see how good, how right we are, how wrong we are, and stuff like that. Because it's good to play right now than when stakes are high, right? Kobe Bryant, Mamba boy, Mamba forever. So that was Control X, just in case if you're wondering. File, save, switch cloud, switch to the, oh wait, what? Oh, Terminal web view. Open editor. Okay, it's here. I never realized it's open editor here. I'm just so used to of like this black and white screen so much because of cybersecurity. I just hardly pay attention to the editors and stuff nowadays. I only use editor when I'm writing some big scripts where I have to like, for example, let's say hack code or like hack a password, right? Go through all those combinations. That's the last I remember wrote something good on a wait, hold on. This lab should be on. Yeah. Wrote a really beautiful piece of code one day. I wrote that. So switch to Cloud Shell and run Terraform init command. Using Cloud Shell editor. You know what? That's taking a lot of time. So I'm just going to ls, right, and cat the main one for a second. This has all our information. We are going to work in the east, and this is our info with this. And I'm going to say clear, or control L also do the same thing. Let's say if I do this and control L do the same clear thing. Terraform init, initializing the backend, initializing provider plugin. So we have mentioned Google, right? This is the version signed by this was created log file, record the provider selection it made above, include this file in your version control repository so that Terraform can guarantee that to make the same selection by default when Terraform init is so in future if you need. So sounds good. Has been successfully initialized. You may now begin working with Terraform. So all the goody good stuff. This is what we got successfully initialized, right? Task 4 is build the infrastructure. Now we will be doing the other resources one. Let us try creating a compute instance without specifying the network parameters, basically, which we not exactly VP subnet it will be in, and see how Terraform processes such configuration. Switch to editor window, main.tf, and enter this block. Okay, hopefully the editor is on. Editor, use legacy editor, web preview. Let's see. Session information. Download up more restart. This is crazy that it's taking so much time. I can just go here, right? I'll just go to main.tf. So I'm just going to go nano main. So at bottom here, separate by one space here. Resource, right? That's the block type of resource we are going to provision, which is Google Cloud Compute instance. Thanks to here, Terraform, right? Is the name of the Terraform instance. Name is Terraform E2 micro. This is the disk and this is the image Debian 11. So our Linux GUI. Let's just yeah, that worked. Let's just cat before clearing everything so it has it, right? So let's just clear it here. Let's go. I should start switching like this. This will be much better, yeah. So I will look more like a programmer in this case. This configuration fails with the following. Okay, we have to first do Terraform plan. Yeah, next time. Warning, duplicate required provider. Provider on main line 16. Provider, this was implicitly required, but instead required provider as TCP, either the local name signed within the resource block. Huh, I see. So maybe we have to go back. Wider Google. I need to check how to do it. Probably I'll like for next video. I'll look into this or when time comes. We probably will see it. Can plan do now? Insufficient network interface. So before we had these two error warning duplicate required provider, right? Must be assigned within the resource block. And we had this insufficient one, but now we are just seeing the insufficient one. So what we can do is here just go a bit up now. Wait, what? Terraform plan. Oh, apologies. Just the insufficient one, right? Main.tf line 16, this Terraform instance, at least network interface blocks are required. So we just have to specify the block. We don't have to specify if we are creating stuff. So the configuration phase with the following error. This is because you cannot configure a compute instance without a network. So we just have to define the network. Now add the network by including the following code segment inside that compute instance block. Let's see if our editor is still, yep. Okay, great. So we just have to go here. We have to do it in this block. And remember there was like with blocks just have extra space. Yes, open it. There's some kind of issue going on here. Let me again check. Yeah. Earlier we were getting some kind of a bug. Oh, hopefully the internet got disconnected here for a second. Hopefully you guys can still hear me. Right now I'll check quick do it. Yep, you guys can. Sweet. So yeah, we were here. We were at the network instance, right? We added this network block. Network block is important. You don't have to specify the network information, just the network block is important. Kind of required. So now let's do the plan. It should work. Cloud shell needs permission to use your credentials for the cloud CLI command. Click authorize. Yeah, let's go authorize. So cool. Oh, okay, beautiful, baby. This one worked, right? So the plan was able to. This will be a create. It will create convenience instance. Can IP forward? No. CPU blah blah blah. Known after instance ID label fingerprint. Terraform. Source things like that. Okay, cool. So let's see. The final code should be like this, which is save the main.tf file, Terraform plan, authorize, do not copy the example. So this is actually how we see it. Now apply. Let's see. We just say yes. It's getting applied here right now. So what it did is similar to plan. It just like did the same plan thing with all the information is still working, creating, still creating. Let's see, our editor is open till then. No. Reload, yeah, let's see. I shouldn't have reloaded it because Okay, creation complete after 17 seconds or 18 seconds. I'm blind, but our editor is still dead. Select project. We are looking at this project, right? I want to see what all not budget, what all instances I have. So cloud overview, CPU compute, estimated APIs, right? We are using all the stuff resources. So I want to see compute instance engine. Yeah, go back. Terraform is the one we created, but for our example, we use Terraform instance. So I want to see what that information is for. This one, let's go here. Details, Terraform, name. I think the Terraform instance. Uh, I don't know why the bad song Bill Jean, not my love, or Thriller. There's some Thriller, one of those running in my brain. I think it is from Thriller, probably. Yeah, what I'm trying to see here is basically, in our Terraform here, we created like, I'll show you. We have this Terraform instance. So where is this information? What this conveys? If we go to images, go back here, Terraform. What does VPC network will mean? Default. Huh. Project ID. This. Samples. Basic VM. Let's see this example, right? What does default? Repeat on not even GCP, Terraform, HCL, syntax, explain. What is example here? What is the meaning of example here? I want to understand that. Provider problem, syntax, image is this. Example here. So it's just a label. Okay, never mind. Label. Yeah, that said it. I forgot with this syntax. It did mention it was a label. labels. Network details. Okay. I don't like the fact that keeps on popping the information one up. I hate that. Hmm. View log monitoring now. So the label, I think that will just be for Terraform, right? If I do plan again, no changes, blah blah blah. Apply. It's checking all that information. I need to go up somehow, but I can't. Never mind. That's fine. We'll look back later. Confirm the by typing yes, we did that. Check my progress. Should work. Verify Cloud Console. 25% done. Adding tags in computer sources. Okay. Come on, come on, come on, boy. And how the hell this goes back? They need to work on these stuff here. Verified Cloud Console, yep, those changes were there. I verified that. Change the infrastructure, adding network tags, editing machine type. So, okay. In addition to creating resources, Terraform can also make the changes to those resources. Add the tags argument to the resources. You must create it will look like this. Okay. Adding the tags. There should be space here. Tags. All are aligned. That's nice. Web and dev. So, and run Terraform plan, apply, the output should be this. Okay. Terraform plan, tilde will show the update. So it's getting update name. Okie dokie dokie dokie. Terraform apply. Enter a value. So let's say if I do just Y, so that's cancelled. If I do yes, apply cancel, it just takes YES but in more. Only this will work. Interesting. That's actually interesting. Huh. Nice to know. 4 changes, block hidden. 4 unchanged block. Okay, yeah. Delay respond yes when prompted, blah blah blah. Check my progress. Editing the machine type without stopping the virtual machine. Machine type of a virtual machine cannot be changed on a running virtual machine. Let us see how Terraform processes the change in machine type for a running VM. Navigate to main Terraform and edit the machine type argument from micro to medium so that it looks like this in here, which we just see. If you look here, machine type here, that's medium. Earlier it is macro. Plan, apply, and all those stuff. Okay. Right now we have here micro. I'll do large. No. Changing machine time, main CPU. Okay. We did, yes, error. Changing the machine time, minimum CPU platform, blah 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 blah. Or advanced machine features on started instance requires stopping it. To acknowledge this, please set allow stopping for update equal true in your configuration. Good part is we that's the one thing about as a developer I will tell you, read through the errors, a lot of answer will be just there. You can also stop it by setting desired status equal terminated, but the instance will not be restarted after the update. Okay, will compute with the compute instance, blah blah blah. Okay, so I'll just add that. Indicates an argument. Oh, I think I know what I did. I said setting as well instead of just desired state. My bad. Terraform plan. So you can see desired state is becoming this, machine type becoming medium to micro. So we just do apply now, baby. Let's go. Now we are looking at these. Looking at this. So still modifying, modifying, modifying. Let's see what this meant here. Popping output, blah blah blah. Allow stopping for update argument to true. So allow stopping for update to true. Plan, run, apply. Yes, machine type will be verified changes in machine type and tags added by a navigate to VM machine. Look at this here. Micro network tags will have def. Oh wait, was supposed to be network? No mind. Network tags, network interface, blah blah blah. Okay, let's you can check progress till then. What I will do here is still modifying. I can at least go here, details. We have tags, dev and web are here, so that's nice. Now storage is there. This is stopped because getting updated, right? I just want to see what it gives me. Nothing else. Reload, yeah. Come on, come on, come on. Give me something. Is the editor still opening? That's pretty bad though. This editor is just, I think, clogged. Modification completed after 1 minute 4 seconds. Uh, okay. Terminal tabs are recovered from existing session. Instance is stopped. Virtual machine instance. Status is this. Let's see. Mm-hmm. Instance ID, description, instance template, machine type medium. Let's go, boy. We got medium. Oh, I see. Medium, check my progress. Come on, come on, come on. Isn't it's good I kept it medium. I did not change anything else because then I had to go back and like I was thinking to do large, honestly. Destroy the infrastructure. I created so much emotions, man. You can now you have now seen how to build and change infrastructure. Before moving on to creating multiple resources and showing resource dependency, you will see how to completely destroy your Terraform managed infrastructure. before moving on to creating multiple resources. Okay, so execute the following command. Answer yes to execute this plan. Destroy specifies what all will be destroyed. Verify that the virtual machine Terraform no longer exists by navigating to VM instance. Check my progress. Congratulations, the lab is done. Okay, doke. I don't like this doing this, but first let me just make sure. Wait, hold on. Should not. Don't have to write all the time. Um, can I start? Start right? Why did not start it? I thought it should start automatically with the whole idea of um changing. Right, like we saw with the last topping for update equals true, it should. You can also stop. Should have at least, like, I thought it's just terminate when it does not start. So that's interesting to know, I would say. It's up and running right now. Set. Even though coming as this, it's running now. Cool. Medium, AMD ROM. Oh, bye bye, good friend. Loki. We have to destroy this, right? Everything will be destroyed. Boom, 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 boom. Going to null. Hmm. Let's see. Refresh. What's going on? I like that. This only refreshes the pane. So destroy. Check my progress. Boy. Check it. Okay. Destruction has still not done. Okay, now it's done. So as you can see, unable to find anything like this. There is no status in nothing. Refresh this. Done. Gone. Boom. Then yeah. And interestingly, our whole editor is still coming up. This is really bad from Google, man. I'm disappointed in Google. Execute the following. This just done. Congratulations. In this lab, you learn how to verify Terraform solution. Define cloud Google Cloud as the provider. Change destroy Google Cloud resources by using Terraform. End your lab and give the rating. I'm actually pretty satisfied. I'm happy with this. Yeah, done in half time. I don't give the best review. I just say nice something. I'm pretty simple words. Um, okay, Loki, let's do this terms and concepts quiz. As you guys know, I'm watching all the comments, right? You guys can see here. I'm watching the comments. Feel free to let me know what is the right and wrong thing if I'm doing anything wrong. And one sec, I'll try to do this. If I'm doing anything wrong, there are chances I might be doing one of these wrong. So please feel free to let me know what you think, what the answer should be, and stuff like that. And let's get started. That being said, LO create, update, and destroy Google Cloud resources using Terraform. In which phase of Terraform workflow you can run pre-deployment checks against the policy library. So which phase you can do the pre-deployment, which is like the validate one and all those. So it is not in the scope. After initialize, plan, and validate. Validate is the one where we do the pre-deployment one, so nothing goes to production which we don't want. These are the security tests one, the one just before apply, I will say. Explain the purpose of Terraform commands. Which command creates infrastructure resources? Apply is the one that creates init, just adds Terraform in it. Plan, just to see what things will go. Format, we should have tried format command. I think I forgot about that. I want to try the format and validate. All good. Explain the Terraform workflow. In which phase of the Terraform workflow do you write configuration files based on scope defined by your organization? Which phase Terraform workflow define configuration file? So I think in the author phase we define all the write the configuration files, right? Everything. Not in the applies, not in the scope, not in the plan one. We do the author one. Let's see. Oh, 100% cool. Sweet, sweet, sweet. Sweet.
This
Under.
concludes Module 2, Terms and Concepts. Before writing code, you'll need to have a strong understanding of the HCL and Terraform concepts that were covered in this module. Let's review. This module described terms and concepts relating to each phase of the Terraform workflow. You learn how to create basic configuration files within Terraform and how to describe a Terraform provider. This module also explained the purpose of a few important Terraform commands. In addition, you learned about an optional phase in the Terraform workflow called validate. You also learned how to create, update, and destroy Google Cloud resources. Check out the next module to learn more about writing infrastructure code.
So that's probably for tomorrow. I'm leaving. Leave this site. Yes. Leave this site, mate. Thank you so much. So yeah, thank you all for joining. I saw like 3, 4 views today, so that was amazing. Um, please let me know where I can improve, as usually, right, and how I can make it more interactive. Um, trying to work, making my things better with the voice and stuff. I know it's hard with the rough voice, but that's, for the time being, that's all we can do. But yeah, any other thing you want me to cover, any other type of course, technology, cloud maintenance things, I'm here to help, right? Or if you have any questions, feel free to ask in the chat. This is my time. I can interact and we can build something together. All right. Till then, thank you so much for watching. 3 people came. It was amazing. So thank you, and I'll see you again tomorrow with our next subtopic towards Terraform. Thank you and bye. Jai Shri Ram.